Welcome to the 130B103 panel, Best Practices for Optimizing Web Applications. Emphasis on applications. I usually do just a quick show of hands about who's in the audience before we start. How many people here are from CDN service providers? You can be honest, okay? How many people here are clients of CDN services? Okay? How many people here are financial analysts that are analyzing technology markets? It's okay. How many of you who are financial analysts, how many of you have done a Gerson call or other expert network call with me? Okay. I don't believe you. But all right. And how many people here make equipment to sell to the CDN market, telcos or other CDNs? All right. So we have a healthier mix than last year. That's great. Okay. So we're going to start with some quick intros. My name is Steve Lerner. I am from Ramp Rate Sourcing Advisors. My firm negotiates contracts for buyers of CDN, colocation, managed hosting, cloud services, and telco. So I'm a negotiator, a contract negotiator. And we've been at this for quite a while. And I will let the panel introduce themselves, starting at Dawn.
Hi, I'm Dawn Parzik, product manager with F5 Networks. We provide application delivery controllers and networking equipment for organizations.
Hi, I'm Jerry Hall. I run marketing for a company called FastSoft. We're the developers of a transport acceleration technology called FastTCP. We help anywhere from large e-commerce social network companies to CDNs speed up delivery, overcome latency through transport acceleration.
And my name is John McElwain. I'm Director of Product Management at CD Networks. We're a global CDN and a bit of a focus on emerging markets.
Great. Very diverse group here. This should be very interesting. So the first thing I'd like to do is start out by defining application acceleration, right? We're talking about optimizing web applications. What is a web application? I'd like to hear each provider's definition of what that means. What is an application? What is acceleration, right, of an application, and what benefit is that supposed to derive? So why don't we start on the other side with John?
Sure. So as a CDN, we tend to look at applications as either internal or external, something that is a business to business or business to consumer that's out on the internet, viewers and users from all around the world, and then also applications that tend to be behind the firewall and more intranet-based applications, something that data is important to connect between data centers. And CDNs do have offerings that kind of tackle both of those, but they are somewhat different in the sense that one of those application bases has diverse audiences, sometimes has flash crowds, difficulties getting into certain geography regions. The other one has issues with accelerating between the data centers and the differences in the acceleration techniques that you can do. So that's how we look at applications themselves generally. Throw in one other thing is just the difference between browser-based applications and non-browser-based applications. So CDNs traditionally have always been known for accelerating web-based applications, but in the past few years, many global CDNs offer non-browser-based acceleration where you can accelerate an IP or TCP UDP type applications, be it a thick client or just a connection that just happens to use the cloud as opposed to devices.
Good. I would define application acceleration as, it starts with a relationship between the application, which is on a server, and the end user, which more and more nowadays is on a web browser. So it's almost like we're going back to the mainframe era, where the mainframe is the server, and the servers are dispersed, in the cloud in one or more locations, and the user is globally dispersed all around the world. We now have web applications that literally have to support hundreds of millions of simultaneous users. Application acceleration is, in my mind, is eliminating that distance penalty for those users that are very far away. It's an attempt to deliver a consistent and acceptable application response time to that user, regardless of where they are. And there's a number of techniques involved in doing that. Our company, we're focused at the transport layer. And one thing I'll bring up is if you look at the entire application layer all the way down to network layer, Every layer has changed and evolved except for the transport. 90% of all internet traffic is delivered over a TCP connection. The most common version of TCP that's still in use today was developed 30 years ago. It's called TCP Reno, and it was developed at a time when the two primary users was DARPA and university networks. And as you know, applications have changed greatly, and for years it was the pipes were the bottlenecks. We now have big fat pipes, even down to the last mile. Even the mobile last mile pipes are getting fat. Yet the TCP protocol remains largely the same. It's loss-based. It actually depends on loss to govern speed, which makes it terribly inefficient. And again, some of the techniques we're going to talk about today are ways to help overcome that. In our case, we focus our efforts on the transport layer.
Great. We look at application delivery from the back-end infrastructure all the way out to the front-end experience at the browser, focusing on ways that the infrastructure can be optimized, looking at ways to optimize the transport of the content, the delivery to the browser, as well as ways to improve that front-end experience. What matters in the end is the end-user experience. If there are problems at any point along the delivery chain, your end users are not going to be happy. They're not going to come back to the site. You're going to lose business, lose employee productivity, and have a number of very unhappy people on your hands. Focusing on everything that's between the browser and the server gives a comprehensive view of acceleration.
Okay, so I want to, for the purpose of making the discussion simple, I want to name two applications to be sort of the standard examples here. The first is the application that runs airline ticketing on an airline's website. Because this is something where, you're running between two meetings, a storm came in, you've got to, reroute and fix your travel so you can get home on Friday, right? And you're interacting with this application, right? We're on one of or many different kinds of devices while you're doing it, right? So that's one kind of application. And you could be in London or in Cape Town or in Jaipur or wherever you are, and you're trying to fix your flights. That's one everybody knows, and it absolutely, without question, is an application. Okay? The second application I like to think about is World of Warcraft, the video game, right? So here's something where you're not probably in a lot of different places, but performance is, and it's not something critical for your business, right? And you're not trying to utilize it to get home, right? When you're playing it, you are probably at home, but it is a very, very intense application, right? Dealing with telemetry data of where your character is in the world of Warcraft, right? And it's a massive game, but the game itself has to be the same and look the same to people all over the world. 10, 15 million people who play it every month all over the world. So these to me, right, and I think are very good examples of what we should talk about in terms of applications. Airplane ticketing and games. Big, massive multiplayer games. Do you guys agree that those are two good things to think about for a CDN, right, applications? Okay. So I think we've all agreed on some definitions here from each of the providers, and we've named two good specific applications to talk about around acceleration. So here's my next question. What specific services that your companies offer, or in the sense, CDNs or CDN-related companies offer, what are the exact services? Give us a name and give us what it does that can accelerate these applications. And remember, let's focus on these two, airplane ticketing and a game, right? What is the name of the product and what is it supposed to do to accelerate, and how will it accelerate those kinds of applications? And let's start with you, Dawn.
Great, thanks. At the core, F5 has our big IP is the flagship product, looking at local traffic manager and web accelerator. For a site like the travel application, you can deploy in either an asymmetric or a symmetric fashion. If you're deployed asymmetric, the devices sit in the data center in front of your web servers. Any user that's connecting is connecting into that data center, getting TCP optimizations, getting offload, getting front-end optimizations. And that works really well if all of your users are in a certain geography. As soon as you start adding additional latency into that, you run into not getting a first-time visit that's optimal, which is where a symmetric deployment comes in. You can put a web accelerator in a data center geographically located close to users, in an office somewhere, and provide optimizations. We have a global traffic manager which will do global load balancing. Based on where an end user is, it will be directed to the closest location. It can be done by IP address, by geography, or by latency. And that combination of products, local traffic manager, web accelerator, and global traffic manager, provides the total solution. So no matter where your users are, they're getting benefit, reduced latency, compression between devices, as well as secure connection.
Okay, so just to summarize, this is hardware.
This is hardware.
Right? That goes in front of a web server.
Correct.
And there's a traffic manager, which is sending users to a best server stack per request. And there is a web accelerator, which is a cache. Is that right?
It's cache and front-end optimization.
Cache and front-end optimization, which we'll talk about in a bit. Okay, got it. Back down the row.
Thanks, Steve. In the, last year at this, there was a panel here that talked about, dynamic content versus static content, and the presenter said, static content is content that it's the same content going to many users. And that's easy to edge cache, easy to move it closer to the user. And then there's dynamic content, which is created on request, right? And that's not cacheable, so you have to use other techniques. And you call that a one-to-one. The reality is, with many of these apps, most of these apps, content is mixed, right? There's going to be a certain amount of cacheable static content. And with our customers, most of the time they deliver that through a CDN, and then the dynamic elements, they could choose to use a DSA-like service. Many times they deliver it from origin, and that's where we come in. We sit in front of typically the ADC, if there is one. And
what's an ADC?
Application Delivery Controller, and we will accelerate that transport all the way out to the other end of the session. In many cases, it's all the way to the end user. We're going to show a case study later. You can see how this works and how much improvement we gave one particular customer. In the case of all the content being delivered by a CDN, a content delivery network, many of these, and hopefully we'll add one more to the list, we actually help in a number of ways. We accelerate pop-to-pop, getting from one CDN edge to the next. We accelerate that last mile, which is kind of an overlooked issue, especially with the mobile last mile and all the extra latencies there. We also help deal with cache misses. So if a request comes in that's not already edge cached, they have to go fetch it from somewhere, and they use our technology. And then lastly, for particularly smaller CDNs that can't afford to put POPs in every possible location, they use our software to extend the effective range of each POP. So we call it POP avoidance. So they're able to provide better coverage with fewer POPs. So that would be our role in those cases.
So to get this straight, so this is a software layer that you add to the web server, is that right? Or do you put it on the server itself?
Okay, thank you. We deliver it as both a hardware appliance. It's software running on a standard Dell server. It's called the ESeries. And what makes it effective is that it can handle lots of traffic. Some of our customers have to handle millions of sessions per gigabit. And so we have to deal with a lot of traffic. It's also abstracted, so it just plugs in. It's a layer 2 device, very passive. In other cases where companies want to they want to integrate us directly into their servers, we have a kernel module that it's a kernel module, and it's also a set of hooks that goes into their existing TCP stack. It replaces the congestion control and the loss recovery mechanism so that we can greatly speed up that transport. We also, as Dawn said with her product, we do it asymmetrically. So all of the changes, all of the technology sits on the server or sending side, and we will accelerate all the way out to the receiving side.
Okay, so again, just to clarify, because when we're talking about everything involving application acceleration, when you say you affect and you have hooks into the TCP stack, are you saying that you're going to change the actual format of the TCP request in such a way that it is going to make it faster to deliver the application? Is that what you're saying?
Absolutely.
Okay.
Absolutely. If you look at and many of you probably don't care to see the technical details about how TCP works, but if you look at kind of a flow of TCP requests and how they're delivered, you see, especially if there's jitter, a lot of loss in the line. TCP is constantly speeding up and slowing down, speeding up and slowing down. And so the effective throughput, or how well you're using that available bandwidth, can be highly inefficient. And so what we do is our algorithms allow us to ramp up very quickly. We proactively monitor congestion. We react intelligently to that to avoid loss altogether so we can maintain a high, steady state. This has a great effect on especially rich media applications, video. We keep the receive buffers full. We maintain a high, steady bit rate. And so by filling the pipe, making great use of the transport, it accelerates the application in a nice, steady way.
Right. The analogy I like to make for this kind of thing is sort of like on your voicemail menu on your phone when you could say you want long prompts or short, right? You have to listen to the instruction set, but you can listen to it more quickly or you can listen to it more slowly, right? But you're still listening to the same set of instructions.
Right.
So, and I just want to make sure for the audience and the people who will be watching this online that it's very clear what he's saying. What he's saying is that the instruction set of how data is transported from one place to another gets changed so that it's faster. I was using TCP 30 years ago, and at a university, talking to other universities, and things have gotten a lot faster since. There's been many reasons why, but the ability to change the format of the instruction set going back and forth, the benefit is very clear. Okay, and all the way at the end. So tell us, remember, to bring us back here, what is the exact specific thing that you're offering? That the name of it and exactly how it accelerates the delivery of an application.
Sure. So our product and CDNs in general that offer dynamic acceleration, our product is called Dynamic Web Acceleration. And for a travel or a booking site for an airline, presumably it's located in a single place because the airline is located there, be it Australia or wherever. End users from around the world are trying to connect in and view the site. I'd agree with other folks who said there's generally talked about two different kinds of traffic. There's dynamic and there's static. The static content could just be the logo of the airline that comes down. Everybody sees the same one. Traditional CDNs have been accelerating that, generally through caching, for well over 10 years. The other technique that is used is the dynamic acceleration. That happens when somebody's looking to buy a ticket. If you're looking to buy a ticket, presumably there's a database on the back end ensuring that the airline only sells one ticket. So it's very important to go to that single data center, again, wherever it's located in the world, and CDNs accelerate that. And the way that we do that is we have a shield POP that sits in front of the customer's origin, and then we have kind of our edge POP locations all around the world. So when the user connects in, depending on where they're located, they get the edge POP closest to them, and then they connect to the edge POP or the shield POP in front of the customer's origin, their website, to get the data sending back and forth. And again, that ticket example is I'm requesting a ticket. You wait for something to come back, and then you could go through the buy process. So there's this process. CDNs, typically the ones that offer the dynamic acceleration, offer binodal acceleration. Because we own both of those two POPs, we're able to accelerate the whole middle mile. And what's interesting about the middle mile is it's probably 95% of the time difference is this middle mile, just because the first mile and the last mile are generally pretty small. And then some CDNs are also able to accelerate the first mile or last mile using asymmetric solutions, kind of like the ones that we've talked about here. So a CDN is really accelerating all of that traffic and is able to push it through the long distance for that fastest response time while you're waiting for that transaction.
So you're saying, but you said that you own both POPs, which is the data center where equipment is located. You own both of those on the origin and at the edge. Is that what you said?
And the edge is wherever the customer is. So if everybody's going to Australia, if you're in Germany, you connect to somebody close to Germany. If you're in Southern California, connect somewhere to Southern California. And then those regions around the world connect back to a Shield POP that's in front of that airline in Australia.
So it is by virtue of your ownership of the locations on top of the software layer that you have that causes this acceleration of applications, right?
It is.
Okay.
It is similar to what we'll talk about, I think, in a future question, which is the walk controllers, the WAN optimization controllers, and some of the vendors here have them as well. When you have both sides of the equation, there's a lot you can do between the nodes, and we're a software version of that. We've chosen to write our own in this case.
But you're a service provider.
We're a service provider.
So you're okay. So speaking of which, so we've got three different approaches for accelerating applications here. We've got F5, which is supplying hardware that the customer owns, right, or the provider who is providing the services to themselves or others owns, right?
Correct.
We've got FastSoft, which is affecting hardware. It's adding software to hardware to improve the transport of data between the source and the destination, accelerating that way. And then we have a complete turnkey service provider in the form of CD networks, right? Mm-hmm. So this, of course, brings a very logical next question, which is, what are the benefits of these approaches, right? Why would someone use a service provider when they can buy their own equipment, not be beholden to a service provider, and run it themselves? Alternatively, why would somebody buy their own hardware when they can do it just turnkey with a service provider? So I'd like to hear from each provider what the benefits are in the case of application acceleration specifically, right, of using their approach, right? And we could start back down with John. Go ahead.
Sure.
And feel free to compare with these other examples here, right? It's not a wrestling match, but it's a seated wrestling match. So I'd like to hear why the service approach is going to be better than buying your own, right? And then I'd like to hear the reverse, right? Why should I go and risk interacting with a third party when I can be operating it myself, right? So we'll go back down. We'll start with you, and then we'll go to Don, and then to the middle. Okay?
Sure. And some of this is just the traditional, build it yourself versus use a cloud-based offering. So it's something that a lot of companies make this decision, have made this decision, and have kind of changed their minds over the years in terms of what they want to do. So CDNs do offer that cloud-based approach where it's very simple to try. It's very simple to onboard. It's also very simple to have multiple vendors to use, either doing a trial or even in production use. So some customers will absolutely use a load balancer, like a cloud load balancer, and run multiple CDNs. So a service-based approach gives you a lot of flexibility, gives you a deployment that is worldwide. Again, kind of depends on your actual application need, but the kind we talked about for an airline is a perfect example of where a worldwide approach is very beneficial because everybody's trying to get to this location to purchase the tickets. CDNs also have many other benefits. They can handle large scale. There's generally a lot of protection built into CDNs. They offer DDoS capabilities. Some offer application firewall. Some have PCI acceleration. They offload from origin, SSL offload. Some of the techniques are going to be very similar in terms of what's offered, the actual acceleration techniques. But generally the scale, scalability, global reach, and the ability to do both dynamic and static of browser and non-browser based applications in the case of that WoW server is what a CDN can really help with. And
well,
that's
that's a general example. I'm talking about specific to applications. Okay, so from my perspective, it sounds to me like if I have a very database intensive application like an airline ticketing mechanism, right? And I build two replicated databases, one on the East Coast, one in DC, and one in San Jose. So I have great international connectivity, and I'm using an F5 load balancer between the two, right? And I'm using fast TCP to accelerate right the data to the end user. I don't understand why a service provider is going to be faster than running this myself, and I don't have to deal with a recurring bill. I can license I can buy the F5 boxes, depreciate it immediately, right? Where is the service provider itself in the case of an application, right? An airplane ticketing engine, why is that better than deploying myself and using these two products in combination?
Well, I guess I would say in the case for
technically better.
Technically better.
Right.
In the use case you're talking about, and we have some airlines and so do other CDNs, you're really going back to a single origin location that has the database. Two people can't buy the ticket at the same time, so it's rather unlikely that this application is distributed with this database. Now, for something that's producing reports, it's a little bit easier, but in the case of an airline, you're typically going back to that server because only one person can buy the ticket at the same time. And what the CDN is providing is not just East and West Coast, and United States might not be that difficult to handle for all of us, really. But as soon as you want to sell tickets to India or Brazil, all of South America, Middle East, Southeast Asia, Asia, you will find, we believe, through testing, and there's nothing better than running an actual test, that locality makes a difference, and that the acceleration will work better and faster by being close to the end user. And our approach is a service-based approach, so you don't have to buy all the CapEx, not just for the devices that are in your own data center, but as the data centers get expanded out to reach these customers.
Right, but to push on this further, right? Dan brings me here because I can drill real down technically. If this is an airline ticketing engine, and I'm serving the world, and I replicate my database between East and West Coast U.S. and cities that are very well peered through the rest of the world as possible, right, based in the U.S., and the database is there, right, and we're talking about the application of the ticketing engine. How is a service-based CDN improving performance in Australia when my database is sitting in Equinix in San Jose? That's where the database is. How is the service itself going to make the application of that ticketing engine, which could be an app that loads on a phone, it could be something in a browser. I might have a bar, it might be a frequent traveler that has a browser bar of some kind for the airline. How is the service itself making that go faster if my database is physically located there?
I guess I would say that the example sounds a little bit more like the WOW server example, which is where a client can connect to one of some regional set of servers or applications that can deliver that. But the database itself probably still is in a single location for something like a ticketing thing, Ticketmaster, or an airline industry. You have to connect to a single location. So in the example of doing that, the global reach allows you to shrink the distance to create what you call a superhighway to connect there.
Okay, how?
Yes.
That's what I'm interested in. How are you shrinking that reach? What is it about the service-based solution that shrinks that reach? That's what we're trying to get to here. Given that the database is in one spot, but there's an application that's using that data. This is what we hear about, application acceleration.
Right.
So what is it about the service that's shrinking that distance?
It's a fact. It's the part that we have, again, a edge and a shield. So we have two POP locations. One could be near the mobile phone that you're connecting to in San Francisco, and the other is near Sydney, let's say, where this website is located in the database that you're trying to connect to. And what we're doing is creating that superhighway from our POP to our POP using walk-like techniques in terms of acceleration, TCP, fast start, and ACK acknowledgement, and there's a whole bunch of window delayed ACKs, selective ACKs.
Right, so what you're saying is that you're acting like a telco, that you are literally optimizing the network flow between that database and another country by transmitting the data. You're actually taking advantage, you're becoming a wide area network for the client. is what you're saying.
Over
here.
the
Is that-
public
Is that
internet.
right? Over the public internet.
Over the
So
public
you are
internet.
literally transporting their data from their database over the public internet under your control
Yes.
out to the other side in another country
Correct.
as a service.
Right.
And it is that network optimization that is creating the accelerated application. That's what's doing. That's what you're saying. Plus
what's doing it.
caching of any static images on the other side.
Sure.
Okay.
They happen.
All right. That makes perfect sense. So next, Dawn. Okay.
The two pieces that you get with a hardware solution that differentiate from a service-based solution is control and security. If you're using a service-based solution, airline ticketing, that all has to be done over SSL. You don't want credit card numbers off in the clear. You then, if you're using a service, that SSL certificate has to be put out at all of these points of presence for users that are connecting to them. With a hardware-based solution, you're maintaining control of your SSL certificates. You also maintain control of where the devices are deployed. If you're only having problems in one geography, you can put a device in a single geography. You don't need to put content out all over the globe. You can specifically choose where your problems exist and where you want to solve those problems. We have a number of customers that are using both hardware and service-based solutions because they don't want to put their SSL, their secure content, out in the cloud and entrust that with somebody else. So they've split the content between both hardware and a service-based solution.
Have you had any customers come to you that say that they've had security problems using a service-based solution for content for accelerating applications?
They haven't said they have security problems, but there is security concerns with their internal teams about putting that content and those certificates out.
Okay, so let's go for the same example of the airline ticketing engine where the database is in San Jose, the client is in Australia, which is a very famous, literally an island of network delay getting there. So what specifically about the F5 solution is going to work, make that application acceleration work? So we've heard that a service provider is acting in a way as a telco that is literally taking advantage, taking control of network transport in order to make things go faster, right? So how is the F5 solution going to do? What is it going to do for the user in Sydney, database in San Jose? How is it going to work to accelerate this application?
Sure. From a web browser perspective, what you're first getting is offload of the static components of the travel site that you're going to cache on your browser. So we're eliminating requests altogether for an application that you're using on a day-to-day basis. All those static assets are going to be cached locally on your device, so you're not even going to issue a request. The only request that's going to be issued are the requests for the dynamic pieces of content and the objects that need to be revalidated and refreshed. When those objects are retrieved, we're providing TCP optimization to the end user, controlling how they're connecting, controlling the number of connections that they open. So instead of opening up 6 connections, do some domain sharding and open up 12 connections to get that content.
Okay, describe what domain sharding is.
Domain sharding is splitting static content over multiple domains. So if you have example.com, you would create domain 1.example.com, domain 2.example.com. Every additional host name that's created opens up additional TCP connections and retrieves content.
So what you're saying is that if you have, so this is good for this audience to understand. So what you're saying is that if you have example.com and you have 1.example.com, 2. And you have 100 of them, right? Are you saying that by using all of those different domain names on a single page, that the page and the applications that call those domains is going to move faster for some reason?
Yes, because you're going to download more content in parallel. For every domain that's open, you're downloading more content in parallel.
And that's because of the nature of TCP, in that you can't request more than one thing from one domain at once over the TCP request. Is that what?
It's between 2 to 6 objects at once.
2 to 6 objects at once. Okay. Does it also possibly reduce the load of the DNS call itself, so that the DNS server doesn't get hit for some reason, or does that make no difference at all?
With domain sharding, you're actually generating more DNS requests because each new domain is a new DNS request that needs to be generated. So you're generally looking at probably wanting to do between 3 to 5 domains. Doing any more than that, you're going to reduce the return because you're having additional TCP overhead, additional DNS lookups.
Okay. Is there a limit to the number of domains that you can shard on for any of this stuff, or is it like typically a company does like 200 and then they just use that pool?
Generally, you see about 3 domains.
3 domains. Okay. And is this done on the fly, or is this something set up in advance? When you do domain sharding, is this some magical technique where you can sort of automatically make multiple domains at once, or is this something that you set up in advance? You know, this is the sharding pool, and then you call them.
You have a brief configuration step before deploying where you specify what you want the domains to be that you're sharding. So you can say domain 1 or whatever you want for that prefix to be. Once that's done on the fly, it is automatically determined. The page gets parsed, and static content that can be delivered over different domains will automatically get rewritten.
Very interesting. Does the F5 solution have sort of an automatic domain sharding renaming on objects so that you can tell let's say the traffic manager, or that would be the web accelerator box, that this group of domains is going to pick from this number of shards, and it automatically relabels on the fly?
You can specify per application basis what you want those prefixes to be for the pool.
Great. So what you're saying is that in the case of application acceleration on an airline ticketing engine, you can break up the calls of that application, right, with different domains in order to make the whole thing work faster, and that your appliance, essentially, your box, the web cache portion of it, the web accelerator portion of it, is going to take advantage of that ability and automatically make an app go faster because it's going to enable the application to use domain sharding as a technique, right?
Correct.
Okay, I got it. That makes sense. Okay, so we've heard about the box-based solution. So now let's talk about changing the transport layer, right? So what is the name of it? I think you already mentioned it's fast TCP, but you didn't mention any specific other kinds of products. You did. You mentioned
fast TCP is the core technology.
Right, that's the technology.
We deliver it in an appliance form factor. We call it our ESeries. It supports connections starting at 100 megabits and goes up to 10 gigabit connections. So our very large customers with lots of traffic will get the 10 gig boxes, and smaller customers will get the smaller boxes. We also sell it as a loadable kernel module in Linux and FreeBSD environments. That's a little more complex because we have to compile a kernel for not only a specific flavor of Linux, but a specific version, right? And then as the customer upgrades their version, and we have to recompile. So it's a little more complex, but to get the best performance, you want to integrate us right into the kernel. And many times we're integrating into already optimized environments, which makes it even more complex. But the customers that want a simple plug-and-play version, they'll get the appliance. I actually would like to answer the question as far as which is better, the box or the service, because in that regards, we're Geneva. We're happy to help the end-user organizations directly, or if they use CDN, we're happy to help the CDNs. Most of our customers use ADCs already. They use CDNs for the bulk of their, most of their cacheable content, and then they use us when if they want control of their SSL traffic and they want to serve it from origin. They want to serve those certificates from origin, and they need to deliver that content, whether it's across the U.S. or across the world. The further the distance, the better we perform. Also, some of the upper layer techniques that are designed to reduce the number of round trips needed to deliver a page, such as what Don had described, actually helps us do a better job. The fewer the objects, as you combine them, you create fewer round trips, bigger objects. That is a sweet spot for us. So larger the file, longer the latency, the more benefit we deliver, and whether it's from the origin site or through the CDNs that we help.
Okay, so speaking of Geneva, you talked about this concept of a kernel. So are you saying that there's a component of the Linux operating system that defines what a TCP packet is, that you were literally replacing, and that you would need to recompile this kernel so that the operating system has literally changed after buying your technology?
Okay, in the case of Linux, Linux uses a variant stack, default stack called Cubic. Cubic follows the same rules as TCP Reno. It's loss-based, meaning it's governed by loss. When I say kernel module, we have a separate kernel module that runs in the Linux environment, and then we have another package that goes and replaces certain components, key components of the TCP stack that's already in Linux, Cubic. I mentioned earlier we replace the congestion control, we replace the loss recovery. We don't replace the entire stack because one of the things that we do when we're first turned on, in every session that gets initiated, we do a round trip measurement. And if that round trip time, or RTT, is 10 milliseconds or less, we won't do anything. We'll just let the native stack handle it because there's not a lot of room for improvement. If that measurement is greater than 10 milliseconds, that's when we take over and we start ramping up very high and maintain that high steady state. So we don't change, we don't swap out the entire TCP stack. We just go in and sort of proxies key functions of it so that it operates better.
Does that work on Windows Server as well?
We have a Windows version as well.
Okay. So in the case of being Geneva for application acceleration, what you're saying is that the origin server still needs to communicate with a CDN service or with a cache appliance, a web cache appliance. So that speeding up, just that act alone is going to make either solution go faster, and the application will accelerate. Right?
Say that again?
So what you're saying, because you said you're Geneva, right, that you work, it doesn't matter either. All of these solutions, you have the airplane ticketing database and its application that uses it. That needs to communicate with either a CDN service for it to take and transport those packets over its own network into Australia, or to the web accelerator appliance of F5, right, which is then going to perform caching. You still need to talk to it. And by replacing the TCP stack on your Windows or Linux server, that alone is going to cause a speed increase because you're talking to the next level of transport more rapidly, right?
Yeah. And just to clarify again, we're not replacing the stack.
Okay.
We're
adding another
we're
stack,
augmenting.
adding an option. You're augmenting, right?
We're augmenting that stack and making that stack run more efficiently. I'll just kind of reiterate again what some of the upper layer optimizations do is they optimize the application. They might, in the case of you have a symmetric option where you have control of both ends, you can do some things to deduplicate the data so that you're only transferring what you absolutely have to. Where we're Geneva is at some point you have to actually transfer something. And when you do, and if you have to do it long distances greater than 10 milliseconds, we will accelerate all of that traffic, assuming it's running on TCP, which again is 90% of all traffic. So that's where we're Geneva is. At the point, some point in time, something has to get sent, and that's what we do.
Okay, so we're forming some very clear options here about application acceleration and sort of the best practices. So we do have like 15 more minutes. So what I want to do is, we've talked about the different techniques. We've talked about where the advantages are. I'd like to now talk about specific use cases, and especially linking to revenue, right? I typically, we make our money at ramp rate via improving somebody's bottom line, right? It's a direct correlation. I'm compensated when someone else's profit increases. I'd like to understand how each of these techniques has been used with a specific client, right? And how, by implementing the solution, it impacted the bottom line of what they were selling, right? So in the case of airline ticketing, there would be fewer dropped ticket requests, meaning more orders went through, orders increased, that kind of thing. And while you do that, I'm going to put up on the screen sort of your case study schematic. So you can sort of point at the screen and say, well, this is how we implemented, or what part of it we implemented for the client, right? I'd like you to either name a client or a vertical. I mean, you don't have to list your clients in front of the public, but you could say this was a game or this was a retail, and we did this, this, and this is what it changed in terms of the revenue, right, that this application is associated with. And I'd like to start with Dawn, and I'll pull up the F5 use case here, and you can sort of point at it, or refer to it. You sent it to me. You should know it by heart.
No, I know. I just want to be sure it's not there. For a lot of our customers, we are deployed both in front of internal as well as external sites. For the majority of our customers, they're looking at bandwidth savings as well as overall end user experience. For one customer, they're based in South America, but they've got worldwide presence. Every user that comes in and connects is taking up a large amount of bandwidth. They ended up going with asymmetric deployment, so looking at kind of the left-hand side, they didn't deploy anywhere else. Any client that came in and connected went into their South American data center. They ended up seeing about a 60% reduction in bandwidth, and were able to save about $400,000 a year in their telecom costs by deploying Web Accelerator and Local Traffic Manager in front of their servers.
Well, reducing cost increases profit. I like it. So, John, let's pull up your schematic here.
All right.
Talk about the use case, and you can refer to this as needed.
Okay. So just real quick on the chart here, it's meant as a kind of a typical use case. I'll throw out two names. I'll try to really quickly talk about iOffer and historic futures. Our website case studies will probably do a better job than I will. But this is kind of the top left graph shows an origin and a CDN. That's just kind of an average, just showing how much better you get. I highlighted out the seconds on the left-hand side. To me, it's not really that important whether or not it went from 3.6 to 2 or something like that, because you're going to get a website that's going to go from 12 to 4 or 20 to this, or, you know, there's always going to be a range, and there's a base level of just what your web application can perform at anyway. So it's more of a range and a ratio that seemed important, and I really thought I would highlight. The bottom one shows kind of the latency of a send or a receive, and again, called out a couple of cities around the world, and like some of the other solutions here, with distance comes greater acceleration. So if you're on the East Coast, you can have your data center locally deliver all your content, and then maybe use the CDN once you get past the East Coast, and you can start to see a ramping rate of acceleration off there. And again, just really quickly, we had Historic Futures, who's a supply chain management company. Now they're worldwide. They have thousands of supply chain vendors all over the place, a lot in Asia and India, and companies like the Gap and Levi's and Walmart are using Historic Futures to understand their supply chain. They had in some regions connectivity that was 25 seconds to just log into the application, and of course the vendor said it was unacceptable, unworkable, unusable, not worth having. So they tried out a couple different solutions. And ended up with CD Networks doing global acceleration. And just an example of some time frames, in China, CD Networks has in-country China delivery where our POPs are physically located in mainland China. The delivery went from 25 seconds to 3 seconds. So it made a huge difference. An application at 25 seconds, they said, was unusable, could not sell, was risking losing vendors who needed to access China, which is almost everybody in the supply chain management these days. So a huge difference, and made a difference between being able to sell and not sell. And then 30 seconds, we also had iOffer. They were in San Francisco. A similar kind of thing. They had worldwide users, needed a global reach for people buying. It's like an e-commerce site. And here's some numbers I know everyone likes to hear. After just 1 month, iOffer measured growth of 4.5% in international traffic, 4% in return visits, 3% in page views, 2.5% in Site stickiness. So these e-commerce sites really do track these statistics and are very much aware of the performance that is being done from the browser, from around the world, wherever their clients are. And, CDNs really help with the whole part of that. Both of these applications were dynamic delivery, for example.
Okay, so Jerry, your turn.
Okay. Great. I mentioned earlier, most web applications deliver a combination of static and dynamic content. You've heard from John, some of the techniques they use for dynamic acceleration. This particular customer of ours is an internet retailer, e-commerce site, top 30. Their target geography is North America, mostly U.S. and Canada. They do over $1 billion in revenue. They offer about 1 million different products. You can see at the top what they started with is you see on the left there the Origin Data Center. They've got very large server farms managed by a pair of ADCs. The static content is delivered to the end user via CDN. In this particular case, they don't have a separate FEO product, but they do their best practices themselves. They've got a large enough staff to do that. And the dynamic content is served from Origin. For whatever reason, they chose not to use a DSA service. But what they did was they contacted us, and what we ended up doing was installing a high availability pair of appliances that are, again, sitting in front of the ADC. The speed up improvement over just the dynamic content you can see at the top there was 74% increase, and the effect it had on the overall page load time was 25%. Tying that to revenue, you saw Joshua's presentation earlier that showed that particularly for e-commerce companies, even a tenth of a second in speed up can have an impact of as much as 1% of revenue. And so they were very, very happy. We actually have some customers that are thrilled with 5 to 10% improvement. This is how much volume they deal with. Whereas some of our file transfer customers and whatnot, their speed up might be 200, 300, 400%. And if we're doing less than 100% speed up, it's not that interesting for them. But certainly for a social network or an e-commerce company where your customer is 3+ seconds away from abandoning you and clicking over to your competition, speed means everything.
Okay, so to sort of summarize here, we've talked about very clear definitions of what an application is, how to accelerate them, what each different methodology does here, and we've looked at some use cases, very specific, of how each one was deployed and how it affects the bottom line, which is what this is all about. So now I'd be interested in some questions. Oh, he told me to go till 3 till 2:35.
Oh, okay. I'm sorry.
Okay, but yeah, it's okay. We work fast here. So questions. All right, we've got a room full of people. There's got to be a few. Yes, sir.
Dual question.
I'll repeat it. Go ahead.
I get the symmetrical model for F5. I'm not sure I really understand the asymmetrical model. Do you require some software or plugin on the asymmetrical side? On the fast off, it looks like there's 2 parallel networks. One CDN static, one dynamic. And does that require different hardware on the customer side or on the network side?
Okay, so the question is, explain again and clarify what an asymmetric F5 deployment looks like. And for FastSoft, explain if in the parallel usage between dynamic and CDN, if it requires more hardware. So go ahead, Dawn, and start.
Asymmetric acceleration, we will do content transformation, change cache control headers on the browser, do the domain sharding to open up more connections, as well as TCP optimizations. Our next release we've got coming out does image optimization as well, reduces the file size, as also Speedy Gateway, which does convert a Speedy request from a browser to HTTP.
Explain what a Speedy
the back
request
end.
is.
Speedy is a new protocol that's been proposed and is front of the IETF to replace HTTP. It does header compression as well as request pipelining. So you're seeing about a 20 to 30% reduction in page load times with that. Nothing's required on the client side for any of these optimizations.
Okay, Jerry?
Okay, and from our standpoint, anything that works its magic asymmetrically means there's only something special happening on one end and not the other. So our technology is deployed only on the sending side. There's no changes, no plugins, nothing required on the receiving end. In the example I showed you, you have an end user that has their browser and they're trying to buy something from their favorite e-commerce site. They think they're talking to a single web server. The reality is that content is coming together from multiple sources. And in this case, the dynamic content is edge cached and delivered from the CDN. The dynamic content is coming from origin to the end user. They have no knowledge that this convergence is happening.
Okay, we're done? Okay. I'm getting the hook. So thank you, everybody.